Okay, today we'll talk about nominal scales. And remember that nominal scales have no inherent order, meaning there's no hierarchy, there's no anything. Nominal scales are just what they are. We typically refer to them or associate them with categories. We have a lot of yes or no answers, true or false answers. We basically are asking, hey, do you like the Foo Fighters? Yes or no? It's yes or no. There's no real one answer doesn't mean more than another. We sometimes do this with open-ended questions when we're doing qualitative data. What do you like about McDonald's? What do you like about school? And people are going to respond all over the chart. And we may ultimately group those into more specific categories, but ultimately these answers just kind of come. Or we have closed-ended questions where we give them a list of items. Which do you like? Which do you not like? And people provide those responses. Again, these are nominal responses. There's no specific order, and there's no one more valuable than another. Typically, with categorical things, we see this quite often in our research. And as you read social science research, you're going to get a lot of this. Some of you may actually do some of this with the qualitative portion. When we get into inter-rater reliability, we'll talk a lot about that, interviewing people, etc. There's no hierarchy again. And when we get an example of categorical data, well, the one thing about it is it's usually very visual appealing because they're often analyzed in a frequency. And when you go in to create a frequency distribution, or as you can see here, what is your favorite color? You had people respond, and we have blue, red, green, and orange. Well, it's neat. We can color those bars to make them match the color and make it really visual appealing. We can put that out there. People like it. It looks good. We could also use the percentage. If there were 100 people, 25%, 16%, 20%, and 15% responded. So honestly, you can think about probably if you've, Lynn Dawson is who I think of. Now there's Steve Harvey is the host, but Family Feud, we surveyed 100 people. This is what they said. Think about that when you think about nominal data. Now, with nominal data, we have to come up with some way to analyze this data, some way to put a statistical number on there, because we need to determine, are these differences or similarities significant? And so we use the chi-square to basically determine the relationship between these two categories or multiple categories. We use this for nominal data, and we use this when the data is non-parametric. Remember, if you're having trouble with that, go back and look it up from last time. Now we denote chi-square with this x squared notation. And the best advice I can give you is when you're going to do a chi-square, go to this website, because it's very easy to put the information into the system and it calculates your chi-square for you. This is one thing it's very difficult to do with Excel, because you'll have to learn the equation and put the equation in, and if you make one mistake, it's all going to be incorrect. There is not a direct output from the data pack that's there from the stat solver. So if you go to this website, it will walk you through and actually show you how to write this thing up in APA style. So if we look at an example, we can see that we're going to look at our color example, except we're going to compare men versus women. And so what is your favorite color? We have the men responding in blue and the women responding in gold. Those are ETSU blue and gold, not to be any other way. Now, when we set up the table, we will set up the table to say that men and women, blue, red, green, and orange, those are the number of responses. Are those exactly the same number? No, they're different. They're different numbers because maybe some people didn't respond. Maybe there are more women than more men. In order to do this, we must determine what alpha is going to be. And we're going to talk a lot about that as we get moving forward later in the semester. But here, alpha is going to be when P is less than 0.05. So that means that we're going to allow a 5% chance of error. Okay, so that's what that means. We're willing to accept that there's less than 5% chance of error. Our total sample size is 152. We add all that together, and our degrees of freedom are 3. And we'll get into calculating that specifically for chi-square later on one of your homework assignments. Now, the chi-square score is 1.0061 with a p-value of 0.799774. Now, this is much larger than 0.05, so this would not be a significant finding. And if we were going to actually report this number it would be x squared. You're going to report the degrees of freedom, the sample size, the chi-square stat, and then the p-value. So it would look like this. Chi-squared is 3, 152 equals 1.0061. P is equal to 0.799, or you could say 0.800, rounding that up. Now, for some of you, that may be extremely overwhelming. And again, the best thing that I can tell you is to go into the book, read the book, go to this website, practice doing some of these, look at the model that you've planned for your research paper. As you look at that model, look and see, am I going to use a chi-square to evaluate these results? Maybe that you will. You may do that. You may not do that. You may look at a relationship in another way. But if you do, think about it. This is a very simple thing to do. So now we're going to move on to ordinal scale measurement, and we'll look at how we analyze those as well.